Okay, so today we are talking about mixed factoring, which is where all the different types of factoring is all mixed up. So step one, you always check for a GCF. It's not always going to happen. So not always there. But you do always need to check, okay? Then step two, you check for one of the following. These are the other 4 types. So we've learned 5 total. GCF is always the first. That's the overall GCF. In fact, here, put the word overall for step 1. That's what we're talking about when we say GCF. Always check for GCF, overall GCF first. Then, if there's 2 terms, it has to be a difference of squares. In other words, it has to have subtraction, and the first term and the last term both have to have perfect square roots. Now, these two have 3 terms. And remember, the basic trinomial or the shortcut has the 1a squared or 1x squared, where the a is 1. So this is the shortcut. But then, if a is not 1, you have to do the full method, okay? And these are both where you have to set up the x. And remember, when you set up the x, when there's 3 terms, we always do a times c for the product and your b for your sum. And then obviously for 4 terms, you do your factor by grouping. And then when you check, you can always do your double distribution to make sure that you get the original polynomial back. And the reason why we go through this in this lesson is because they're all mixed up. Okay, so just get in the habit. So first, let's check for an overall GCF. So in this case, between 28 and 63, let's see, 7 can go in. And they both have a B. So the overall GCF is 7B, okay? But you just have to remember your overall GCF has to go in front of the final answer. So when we divide that, we get 4a squared minus 9. Well, notice there's 2 terms left. Well, guess what? That fits into this difference of squares. So when we can factor this, we just have to remember to have our 7b out in front for our final answer. We square root, well, 4a squared splits into 2a and 2a. And then we need our plus and our minus so that the middle terms cancel or add out, and then we factor the 9 into 3 times 3. So we have our positive and our negative 3 to get your minus 9, and we're all done. So like on number 3, immediately I would notice there's 4 terms. Now, I already know there's no GCF. My eye is trained. You'll get to the point other than 1, okay? Like 1 just only works when you're doing your factor by grouping. But when it comes to an overall GCF, notice as soon as I saw that this has a 1x cubed, I know I'm not even going to check the coefficients, because as soon as there's a coefficient of 1, that's it. And then I noticed this has an x cubed, but this has a y. So they don't all have a common variable. So I'm going to go straight into the factor by grouping. So I group the first 2. But remember with this minus, you got to pull that minus in, and we know the GCF for the second pair is going to be negative. So we know that the GCF for the second pair is negative 4, because we want the signs to match. See how the first pair, both signs inside the parentheses are positive, and the GCF for the first pair is x squared. So you get x squared times x plus 2, and then the GCF of the second pair is negative 4 times, and then you get x plus 2, again because negative divided by negative is positive for both factors. Now the last step, we take the 2 GCFs and the x squared minus 4, and we put those in as the first factor, and x plus 2 is your second factor. Now we're actually not done, because now we recognize, oh wait, see this x squared minus 4? That's it's a difference of perfect squares. So we can actually factor this one more time, okay? So this actually, the x squared minus 4 is x plus 2 and x minus 2, but then we also have this other x plus 2. Now, some of you that are going on, I hope you already recognize there's two factors that are exactly the same. Well, we have to use a square then. There's only one factor of the x minus 2, so I'm going to start with that, x minus 2. And then I have the x plus 2. I'm going to put the squared for the final answer. Okay. So just make sure this time with the mixed factoring, like if you finish factor by grouping or something to that effect, you may have another factor that there's two terms that are also a difference of squares that you have to factor further. And then just rearrange them so that if there's any repeated factors, you write them as a square or a cube if that happens to be the case. So now look at number 5. We know the overall GCF is going to be 3w. So then 48 divided by 3, what is that? 16w to the 4th minus 1. Now automatically I know, again, my trained eye, and this is what I want you to recognize, a difference of perfect squares. Well, we have a difference. There's only two terms, okay? And when you have an even exponent on your variable, that's automatically a perfect square, and 1 is always a perfect square as well as 16. So I can square root both terms. In fact, I'm going to write it over here because I can already tell this is going to be a long string, okay? And this is definitely one of those, if you're going on to honors, you're going to want to master for honors algebra 2. So first of all, we need the plus and the minus. The square root of 16w to the 4th is 4w squared. And the square root of 1 is just 1, because 1 times 1 is 1. But now, notice, we're not quite at the final answer yet. Pluses will never factor when you have two terms, except for you'll learn sum of cubes in algebra 2. But when we're talking about squares, only the minus with the squares factors. And guess what? These are still perfect squares, so I can split this into two more. I can split this one into 2w plus 1 and 2w minus 1, and I still have this 4w squared from up above, and then I also need my 3w, and there is your full factored form. So not only are we mixing up all the factoring, but you got to start recognizing that, hey, once you finish factoring one step, there might be a second step on one of the factors to keep factoring. And it's most common on the difference of squares. Okay. So, all right, now look at number 7. Automatically, I know there's 3 terms. But remember, we have to check to see if there's a GCF. I never, ever do the x until I take out the GCF, the overall GCF, because I want to work with the smaller, more manageable numbers. You do not want to do the x with the GCF in the problem. So in this case, I notice that they all have minimum of 2 x's, and let's see, 4 can go into all, so 4x squared is the overall GCF. And so when that reduces, we get 2x squared minus x minus, what is that, 6. Okay, now I do the x for this trinomial. And I do my a times c, so 2 times negative 6 is negative 12, and the b is negative 1. Well, I know I need a negative times a positive, and negative 4 and 3 since I need more negatives. So I have to do the full x method because there's a coefficient in front of the x squared other than 1. Okay, so when the a, or the number in front of the x squared, is not 1, you have to do the full steps. So we have to replace these two with as our new middle terms for the old middle term. So we get 2x squared minus 4x plus 3x minus 6, and then we do our factor by grouping. So the GCF in the first pair is 2x, and the second pair is 3. So we have 2x times x minus 2 plus 3 times x minus 2. So then this, I just need more room. Oh my gosh, this is... maybe I just write too big. So if I take the two GCFs, I get 2x plus 3, and then the x minus 2, and then I might as well put the overall GCF 4x squared in front. And I know I can, that's my final answer, and I'll tell you why. Because notice there's no more squares in our factors. So there's not, even with the minus 1, there's no more squares, and by the way, 2 is not a perfect square, so I couldn't go any further anyways. Whereas this one, we had a minus with 2 perfect squares, okay? So we had to go further and break that up. But this one we can't, so we're done. Okay. Number 9 is another factor by grouping. I'm just going to let you guys do that like number 3. But look at number 2. So we have the overall GCF. I can already tell between 3, 9, and negative 30 is 3. So we divide it by 3, and we get m squared plus 3m minus 10. Now I automatically know I can do the shortcut because it's a 1 in front of the squared variable. Okay. So when I set up my x, the a times c, or 1 times negative 10, we have negative 10. And then our b is 3. So we need a negative times a positive. We know 5 times 2 is 10, and we want more positive, so the 5 is positive and the 2 is negative. But remember, because it's a 1m squared, I can go right to the final answer. Just don't forget the overall GCF in front. But we split up the m squared, so it's m times n, and then the minus 2 goes into one factor, and the plus 5 goes into one factor, and we're done. And to check that, you could do the double distribution of the two factors, then distribute the 3, and you'll get the original 3m squared plus 9m minus 30. All right. I'm pretty sure we covered all 4 types. Now again, I just want to review. Sometimes you're going to have to factor further, like these two, and do basically like a double factoring within the problem. And you might have to rearrange your factors if you have more than one of the same kind, because you always want to put them together with a square on the outside, or a cube if there's 3. Anyways, so keep going with that. Check for an overall GCF first, and then determine by the number of terms what method you use. Okay, stop the video. I'm going to put the answer key up so you can check to see. I'm looking for work when you turn it in. Guys, see all these steps? And even with the shortcut, I show all this work. I'm looking for this work for